want you to look around the room that you're in right now, and I want you to notice some things about it. Just whatever you can kind of see. So I'm gonna do that with this pretty nice bedroom that you see in front of you here. So I'm seeing, let's see, this has blue walls. It has maybe some soft pillows if you touched them, and it has a squarish looking tabletop and maybe a carpet that kind of feels rough on your feet and a 3 foot long double-sided Sith Lord lightsaber. Well, all of these things that we're talking about here are what are known as physical properties. Don't forget that red slides are where you have to take notes. You should have your notes handout ready to go. Don't forget to look for the owl and let me know where he is. And remember to fill in all of this stuff that you see here. So what are physical properties? Well, physical properties include things like color, state of matter, density. Density, when we talk about density, you might remember Archimedes, right? And the naked old man guy, right? And his quest to figure out whether the king's crown was really made of gold. And one of the things that he knew was the density of gold, which tells you something. That tells you that it doesn't matter what gold you have, whether it's a gold ring or a gold nugget or a gold tooth or gold leaf or whatever, gold has a certain density to it. It doesn't matter how big or small the piece is. It doesn't matter what shape it's in. Gold has a certain density, and any piece of gold has the same density. We'll talk more about that in class, but that is a property of a certain type of substance. So for example, lead has a certain density. Oxygen has a certain density. Every different type of material has its own density. Okay, freezing point, boiling point, those are physical properties. And solubility, what does that word mean? Well, think of this picture. Solubility, you may remember doing a lab that included some Alka-Seltzer. Solubility has to do with the idea of how much something is able to dissolve in something else. In other words, how much of this solid substance like sugar can you mix into this liquid like coffee and have it stay kind of suspended in the coffee, have it floating around in there and not just sinking to the bottom. That is a property of a substance too, a physical property. Now, physical changes. So when we physically change something, well, what is that? It's this. All right, so that's all great. Those are fun little videos to look at and stuff like that, smashing things and all that stuff. But what exactly does it mean that you don't change the chemical properties of something? Well, I want to give you a couple ideas of this, but we're going to talk a whole lot more about this. In fact, this is mostly what we're going to be talking about for the rest of this semester. So I want to give you just a brief little example here. So right here, I have a picture of some water and a picture of the periodic table of elements, which is sort of the building blocks of all the stuff in the universe. And I want to take a couple of parts of that periodic table and I want to show you something here. So I'm going to take some hydrogen and I'm going to take one more hydrogen and I'm going to take some oxygen. And if you stick those three guys together, well, you might know where I'm going here. You get yourself a water molecule. And so when we stick those three guys together, that becomes water. And I think you guys would all agree on this idea that water is different than, say, than oxygen all by itself. Oxygen is kind of in the air, it's clear, it's a gas. Water is different, right? So I just want you to think of that idea of if we were to take apart this molecule right here, and if we were to separate the hydrogen and the hydrogen from the oxygen and kind of pull them apart, that would be a chemical change in the substance. So when we do things like cutting a piece of wood in half or ripping a piece of paper in half or smashing some glass or something like that, it doesn't do this. It doesn't take apart molecules. You might separate this water molecule from another water molecule, but you don't actually take the hydrogen and oxygen apart. In other words, if you were to drop a rock into some water and splash it around, you get water all over the place. That's a physical change, but you don't get a bunch of oxygen floating up into the air and hydrogen floating out into the air. This guy stays together in one piece. So that's the idea of what the difference between a chemical and a physical change. If this water molecule stays water, if it stays connected together with the two H's connected to the O, then that is, you have not made a chemical change there. If you want to make a chemical change, you actually have to break apart this molecule, and that's not something that you're normally doing just by kind of smashing and cutting things. All right. Here's another example that we can talk about. So here you have this substance here, and you might be surprised to know that this stuff that looks like a gray shiny metal is actually sodium. And this stuff that's in this little container here, that yellowish greenish gas, is chlorine. Now, you might think, well, I've heard of sodium before. That's like what's salt, right? And chlorine, that's some stuff that's in your pool. Well, by themselves, these actually can be very dangerous things, and they look kind of unusual, or they look unfamiliar, I guess you would say. Not what we necessarily would think of. You don't really think of this yellowy kind of gas when you think of what's in your pool, and you certainly don't think of a gray, shiny metal when you think of what's in salt. But by themselves, sodium is actually something that's very dangerous. If you put it in water, it catches on fire and explodes. Chlorine is also extremely dangerous. It actually was used by the Nazis in World War I as a deadly gas to kill people. But if you put them together, what you get is salt. But that involves a chemical combination of sodium chemically combining with chlorine. Now, I think you can kind of agree with me that if you took a hammer and smashed this salt, you wouldn't break it into things that looked like sodium and chlorine. You wouldn't be breaking apart the actual molecules. So that kind of is, again, the difference between what we would think of as a chemical change, where you would actually have to chemically go through some chemical reaction to break this salt down to make it back into its individual parts of chlorine and sodium, versus a physical change, which would be like hitting this with a hammer or something like that. So, a physical change is a change in matter from one form to another without a change in physical properties. And that also includes changes in states of matter. You understand that this right here, the liquid water, and this right here, the solid water, well, they're both water. They're both made of H2O molecules. And so when you do something like what you see in this picture, when you melt this, it's still water. You have not broken apart any molecules. You have not taken the hydrogen and separated it from the oxygen. You've just gone from solid water to liquid water. So a change in state of matter, this is the one that messes everybody up. Remember, changes in states of matter are a physical change, not a chemical change. All right, fill in these boxes in your notes as we go. So we have solid, liquid, gas, and do you remember the last one? Plasma. Now, when we go from a solid to a liquid, you know what that is, right? Melting. When we go from a liquid to a gas, when we change from a liquid to a gas, that's going to be evaporation or boiling. When we change from a gas to a plasma, that's going to be ionization. That word's not going to mean a whole lot to you right now, but it'll mean a lot to you later on. It basically means that the electrons are getting kicked off of the atom. When we go back from plasma to gas, it's deionization, just the opposite. When we go back to a liquid, it is condensation, and when we go back to a solid, it is freezing. And there's one more that I left off here. Do you remember the dry ice going from a solid to a gas was sublimation? So go ahead and get those all filled in. I'll wait for you. Take your time. Are you done yet? How about now? Well, if you're not done yet, just pause the video. All right, so those are the basic things you need to know about physical properties of matter. Those things include things like color, state of matter, density, freezing point, boiling point, and solubility. And we learned that a change in matter from one form to another without a change in physical properties, that is a physical change. And this includes, remember, a change in the state of matter, and we will talk about this in great detail this week in class, and I will see you then.